So once again, a very warm welcome to this webinar, which is the second webinar in our series of Inspiration webinar series for phase 2 of the India Smart Protein Innovation Challenge. This is Shardul Dabir, the Innovation Specialist at GFI India. And today with me, we have Devika Suresh, Innovation Associate of GFI India team, and Akshay Bhatt, who's our SciTech Specialist, focusing on cultivated and fermentation categories. We are quite excited to have Dr. Gurmeet, who's an expert speaker from Transdisciplinary University, Bangalore today. He's been working with a lot of startups, has been training PhD scholars on extrusion technology, especially when it comes to its application in alternative protein. He's been doing some pioneering work with a high moisture extruder present in his lab, and along with it, a lot of other tools and basically equipments that are needed for novel research and new product development in the sector. He's been conducting a lot of webinars and master classes with the GFI India team over the past couple of years, attended by various industry professionals from India who want to understand that part of the value chain, because as you all know, the problem of high moisture extruder is a big one, and having less of them, or even in fact very few of them in India, means that entrepreneurs and students find it very difficult to get practical exposure and understanding of how this technology really works. And perhaps to accelerate the growth of the sector in India, we need to make sure that such more facilities exist throughout the country, which is what GFI India is also striving towards over the next few years. Having said that, today's topic is plant-based meat primer, and Dr. Gurmeet has been working on texturization and undertaking research in that area. So he has a lot of interesting things to share with us. And towards the end, like I said, we'll be taking the questions, but feel free throughout the session. No question is small or insignificant. Feel free to use the Q&A button or the chat function to send in your questions, or towards the end, you can also raise your hand and we can promote you so that you can speak as a host, and we can get that question in that way as well. Having said that, really quickly focusing on who's made this possible. So all our sponsors and supporting partners and smart protein ecosystem partners on the India Smart Protein Innovation Challenge are kind of enabling the prize pool, which is at the current date almost 20 lakhs for up to 20 teams. So 1 lakh per team. We are hoping to choose 10 winners in each of the tracks. And you're working on very interesting set of RFPs and problem statements now, and hoping that you find a lot of support and perhaps collaboration and synergies within these ecosystem of partners pose the challenge as well, and in phase 3 and 4 through some of these sessions, like with Dr. Gurmeet, who's a mentor for phase 2 and 3. So these are some of the RFPs which are relevant to today's session. In track 1, production of improve plant protein structures and filamentous fibers, which improve the overall sensorial experience, whether it's through extrusion or other such texturization techniques. Today we'll be largely focusing on extrusion, but Dr. Gurmeet might be able to answer some of the questions similar in this domain as well. The other one, which was the second RFP or problem statement in track 1, was about creating plant-based meats or milk or other such products, but this one is focusing on milk, but similar RFP exists on the production of meat, eggs, and dairy from indigenous crops in track 2. So their plant-based meat production technology is quite important to understand. Then we also had this track where plant-based meat, plant-based seafood texturization and its applications in a country like India, which we are focusing from a theoretical perspective. And then in track 2, we have the B2B upstream ventures, kind of a statement or white space opportunity area, where again, entrepreneurs are thinking about ingredients, the end products that would basically be necessary, whether it's texturized vegetable proteins, the kind of flavor and ingredient toolkits needed to replicate the plant-based meat, sensorial experience and textural experience, etc. And at the same time, in statement 2, you're also literally focusing on creation and manufacturing and scale up of plant-based meat ventures, and basically with the focus on texturization and also thinking of expert-oriented products and understanding the science and technology behind it, and kind of finding innovation within all of that supply chain. Having said that, I would also just like to quickly take your attention to the fact that extrusion is a technology which makes a lot of these products unique, because they might not be offered in the current form in the market. They could be shelf stable. In case of HMEs, they might still require frozen or refrigerated supply chain. So there's also a lot of opportunity here to innovate for a country like India, where you have to think about distribution and channels of supply chain quite closely if you want to succeed as a food manufacturing startup. So yeah, that's just that. Like I said, questions throughout the session and towards the end. And with this, I'd like to invite Dr. Gurmeet to share his insights and presentation with all of us today.
Thanks a lot, Shardul. Thanks, Devika, for this session. And yeah, let me just start by sharing my screen. Okay, you can see this, and let me put it on to. Okay, everybody can see this? Yeah.
Yes,
You just can hear me. Okay, so yeah, so today's topic around texturization, but I have experience around the whole innovation process. I mean, created a little startup around tea a little while ago, and also offer a course around innovation from the idea stage to developing concepts to prototyping to all the way to market with a claims roadmap and a technology roadmap. So if you have questions around that space besides the technology, feel free to like bounce them off as well. Yeah. But today, for the purpose of this, the talk, the first half an hour or so, I have a few slides just to set the context. Yeah? And since GFI wanted around strategic view around texturization, thought I'll put a few slides around that. Yeah? Also, feel free to ask questions in between, right? Stop me. There's no particular reason to run through all the slides, yeah, as such. So do feel free to stop me and pick up a discussion. Just to introduce, I think we're all here. We know what we eat affects us in many ways, right? Sustainability is the COP26 talk of the town. And certainly plant proteins become important from that perspective, right? Not just plant proteins, I would say it's the broader area of alternate proteins, because plant proteins themselves are a restricted set of, have their own constraints, right, around there. I think bigger, if you're looking at the Indian context, I always look at point number 2 and point number 3 more than point number 1, because point number 1 is very critical for a beef eating country. In India, beef is minimal, uh, and uh, and so point number 2 and 3 are more critical, which is around balanced diet, protein to carbohydrate balance. If you do a quick evaluation of are we a protein starved country? Well, we produce enough protein for, if we just look at our requirement of about 50 to 100 grams of protein per person, then we produce about 80-90 grams of protein, right? But our challenge is that a lot of our protein comes from not from protein dense foods, but from, say, cereals, which are 782 to 7-8% protein, typically under 10% protein. And therefore our protein comes with a lot of carbohydrates, right? So it's the balance part which is a issue rather than a overall shortage of protein. Yes, for sure, there is an uneven distribution of protein, that not everybody has equal access to proteins based on socioeconomic divisions in the society. But the other challenge, the protein carbohydrate balance, right? And so we're looking for protein dense sources is my area of research, right? And then the other part in there is that even if we have protein dense foods, such as say legumes, the amino acid profile is a thing that we need to keep in mind, right? Because uh, a lot of the proteins from plant sources are not complete by themselves. If you have an egg, if you have paneer, if you have a glass of milk, if you have meat, they are complete sources of amino acids. They have a good amino acid profile. One plant protein from a single plant usually is not complete in its amino acid profile, and therefore when you are looking at plant proteins, you have to be intelligent about it. That is, you have to make sure that you are eating the complementary ingredients together to balance your protein. So those are two challenges for India, right? The third, of course, is improved digestibility, that plant proteins are also not as easily digestible as the animal proteins. And so it's not just the quantity of proteins and its amino acid profile, but you're also looking at digestibility, which is a little more than just the profile and the balance. Yeah. And so anything which can solve all these three issues would be a area which I would say is a food futures area. Within our university, I come from a small university in Bangalore, transdisciplinary university. It's near Yelahanka, set up about 10 years ago, and we focus largely on research aspects. And one of the research areas, I had a department called Center for Ayurveda Biology and Holistic Nutrition, where we look at traditional knowledge systems and modern knowledge systems and the synergies between the two to solve some of the existing challenges that humanity is facing and the future challenges. So one of our programs is around food futures, which is where this whole area of sustainable foods fits in. And we look at how do we create balanced protein foods by mixing the legumes with our traditional grains like millets and even wheat and rice, the traditional varieties. And of course, none of this makes sense unless you address taste and texture as well, right? So whatever we do, we don't eat food. We will never make a selection just based on sustainability or just a balanced diet or just digestibility. I want my taste and texture, right? It's always taste first and then health, taste first and then environment, taste first. And so that's human nature. So we need to make sure that we have the hook of taste and texture, right? And everything else follows. So when it comes to taste and texture in the context of plant proteins, yeah, there are two broad areas to focus on, right? One I call as designer plant proteins, right? Which is the ingredient, right? Then how do you come up with these designer ingredients? Designer ingredients uh, with all the characters, the functionalities that we want, not textural functionalities, and we'll talk about that, but also any other functionality that you put in. I spoke about sustainability, spoke about balanced diet, spoke about digestibility, right? So you have to look at this as what are the aspects that you want to put into this designer ingredient. So how do you create that? And the second part is, once we have a designer ingredient, how do I convert it into a put the culinary science part in it, right? Today, culinary, I think till about 20, 30 years ago, culinary part was considered as an art. Today, we look at culinary also as a science part, right? Because it's the product structuring, product design part. Yeah? Started, I mean, you can trace it back to probably the world of chocolates, for example, comes to mind, where no, the whole structural part and throwing physics at it, phase diagrams at it, started evolving, and that's what has taken off. And we see the molecular gastronomy as an area, right, coming up from there on, with the Lints of the world and the Cadburys of the world leading the way there. So these are two broad areas. What do we do at the designer end for ingredients, and what do we do at the new product design or product structuring end, right? In a kitchen or an industrial kitchen, in this case, if you're looking at innovation, which always has a size component to it, right? It's creativity done at a scale. So those are two places that we intervene. And always, I think when we begin, if you're looking for since we look at plant proteins, largely the interest seems to be coming in, can we mimic meats with plant proteins, right? That's a very interesting statement. Can we mimic meats in terms of plant proteins? And if we make that as a statement, as an ambition to look at, then there are multiple subsets there as well. I mean, there is the world of minced meats. There is the world of whole meats. Let's just focus on minced meats. It's a easier problem. Easier, I say that it's the first problem. It's by no means it's fully solved. But that's where a first generation technology would look at, right? The whole meats would become a second generation or third generation technology. So looking at the world of mince meats, there are a number of different products. I have 5, 6 named here: burger patties, seekh kebab, galautis, the fried categories, the nugget categories, which are the coated mince meats, the breaded mince meats, the sausages, which are within encasings, etc. So you have a number of different things. So whenever you begin and you try and address, it's always good to begin with trying to understand the product that you are targeting, right? And learn as much about it as possible. When I say as much about it as possible, it's the whole physico-chemical nature of the product, the ingredient composition, the historical. How did that product evolve? Why did that evolve? What is so unique about this versus other products, etc. It's good to go into it. And this chart is by no means complete, but just a rough that if these are the products that we encounter, then is there a specific meat that they are associated with? Today, of course, you can get a Sikh with anything in it, right? I mean, you can have a mutton, you can have a chicken. It's just a shape that we've reduced it down to. Similarly, with Shami, it's a shape that we've reduced it down to. But typically, they are associated with a certain meat, with a certain mince size, with a certain binding system which comes in. For example, shami kebab, typically if you go to traditional houses, uh, you will see that a chickpea is something people use very commonly at homes as a binding system. Anda is commonly used as a binding system there. Cutlets are usually nowadays with binders, which are more from the molecular gastronomy end. Sausage is a very interesting classical product, which is, people call it as an emulsion, because you actually use salt to emulsify the fat, animal fat, with the water, yeah, in it, using the proteins as the emulsifier. And to get the proteins to solubilize so that they can actually then act as emulsifiers, you need to have a certain salt level, and then you put it into a casing, because otherwise it's too soft, right? And as it cooks, it hardens. So it's an extremely interesting product. And today sausages are all over. We don't need to get to the natural emulsions, because we use a lot of other emulsifiers to get the job of holding fat and water together. Burger patty is another product, much more coarser typically compared to others. Nuggets, as I said, is a batter and coated product, and typically denser, right? Because in nuggets, usually, because we are using mince, we are coating it. So we use a lot of the parts of meat which would otherwise not be used, right? And so they get minced, they get shredded, and they are packed together very densely in vacuum, right? And many times you use vacuum process to get to a dense packing. Can you all hear me? Because I seem to have a power cut here. So
Yes, I think you can just take a minute if it comes back on. Otherwise, we can continue as is.
we can continue. No, so it's fine. If I drop off because of, yeah, cool. Okay. So this is a statement I like. I mean, it's in popular literature, it is popular online literature. It is associated with Galileo, but you dig deeper and you realize maybe it's attributed to him, but he was not the one who made the statement. But I like the statement a lot, and I call this as the difference between, say, the modern science and pre-modern science, right? Which is measure what is measurable and make measurable what is not, right? So around 15th, 16th century is when modern sciences took off with this concept right behind it, that can we just measure everything? Because otherwise we keep discussing things is anecdotally, right? And the emphasis on measurement started about 500 years ago, and that's what catapulted us into this modern era of science. And I say that, hey, we are now stepping into a, a new era of plant proteins, and a new generation of products associated with it, right? And if I just take a minute or two to say what I mean by this is, there are three macronutrients that we talk of. There are carbohydrates, there are fats, and there are proteins. Uh, Purification of carbohydrates from their agricultural or their ingredients, right? Basic agricultural ingredients happened 2000 years ago, right? Where we got to pure sugar processes, right? At least the good kind of process, and then refinement has happened. And so we have 100% carbohydrate available at about 20 to 40 rupees a kg, 40 rupees a kg if you're going for sugar, right, which is available. Similarly, fat, animal fat and butter, of course, is again a 2000-year-old technology, 1000-year-old technology. And with plant fats, very few, but the cheap ones start becoming available only about 100 years or so. So plant fats have become very popular over the last century. But before that, we were largely animal fat species. And so that pure fat is available at about 100 rupees a kg, right? So pure carbohydrate at about 40 rupees a kg, and pure oil, agar aapko chahiye koi vegetable oil, you'll get about 100, 120, 130 these days because of suddenly the cost escalations. But that's where we were. It's 100-200 year old, right? If you look at proteins, largely protein has been as meat or legumes. 25% of the weight of whatever we are consuming was protein. There was a bit of technology introduced in extracting proteins and from plant sources and converting it into products. And that's the tofu technology, right? Which you can trace back to a few hundred years, right? But nothing beyond that, right? So we've not gone to beyond 40% protein products, right? In food sciences, in our evolution, human evolution. It's only very recently that we have started looking at protein isolates and they are becoming available at almost near 100%, right? 95% protein powders from plants. Animals ka thoda jaldi tha because whey powder has been available for some time now, but plant proteins is very recent that we have started, and the quality was not too good. 20 years ago, I was involved in projects in industry. I used to work with Unilever, and I was looking at soy was a big category for us, soy milk. And we would struggle in getting good taste with soy milks because soy plant proteins had this significant beanie notes associated with it. If you look at 20 years from then to what I look at now, we have, they are transformed products. We may still feel that it is a little beanie, etc. But if you've experienced things 20 years ago, you will realize that there's a dramatic improvement. And this improvement, so that now with adding flavors and other things, we can really mask those notes, right? And it's not that big a challenge as it used to be, right? Earlier, it is now more of a product development challenge as opposed to I don't have a good ingredient. Good ingredients are available if you're willing to pay for it, right? And so a lot of this has happened because of this focus on measure what is measurable and make measurable what is not, right? It's a new area that we are stepping into, and it is for the pioneers in India who are into this, that do we want to do it as a jugaad, as we call it, and so proud of it, or would we want to go deeper into the quality aspects of it, the measurements aspect, and create something which can go not just be a big product in India, but also go global from there off. And to do that, if we come to the world of texture, we need to start going into the bite, the mastication, going into our biology, our muscular biology, etc., of our jaw. And this work has been done a few decades ago, where scientists went around trying to understand and quantify this whole process and convert it into a metrics. And the texture analysis area was born, right? And today we have quite a few companies who sell very good texture analysis meters, which allows us to get to some quantitative replicable data. And we've come up with definitions relating to consumer language. So going from a very equipment which has been the workhorse of material scientists, measuring compression tests and tensile strengths of materials, to applying them for understanding food, and at least from the texture analysis and looking at texture profile analysis, and come up with terminology like fracturability, hardness, cohesiveness, springiness, chewiness, resilience, and relating it to a compression test. If I take a piece of food and I press it, and I measure the force with which with which it presses as a function of how much of distance my probe has moved, which is how much of compression has happened to the food, which is on the x-axis. That compression is on the x-axis and force is on the y-axis. And the area under the curve, for any of you who are physicists will realize that this force versus distance curve is the area under the curve is work, right, or energy done. So that starts giving us an idea of the hardness. So different points of this curve, whether it's the first peak or whether it's the area of the, by doing a 2-bite test, which is pressing once and then a second, which is what this curve indicates. It's a 2-bite, simulating a 2-bite test. You can come up with how cohesive the product is, how springy the product is, how chewy it is, how resilient to deformation it is, how hard it is, and come up with quantitative data that helps you understand. So we went around in our lab, we went around sourcing a lot of products from all over, from our Galika restaurants to all the delivery restaurants to the Taj Hotel ke products to the ITC products to various, right? To see what is a Sikh, right? What is a sausage? What is a galoti? What is a burger kind of a patty? What is a cutlet? So how are these restaurants, etc.? Does it make sense? And of course, we were expecting things to be all over because, but we do start getting some patterns, right? We see the galoti kebabs are hardness levels kahan pe hai, like, I mean, if I take a 500-gram weight on a galoti kebab, it will go down 50% very easily. Whereas if I need to compress a Sikh kebab by about a 50% or so, I need to put in a weight of about 2 kgs on it, right? So those are kind of things which start coming up and you can start relating. So these are charts that, for example, hardness versus chewiness or resilience versus cohesiveness, which seem to have some relationship between them, right? Cross correlation with each other. And we can look at these kind of mappings and understand where products are, right? Kiska product kahan pe hai. And so when people come to our lab, we work with about 15 or so different startups and companies. You know, our first thing is that for us, it is not sufficient to know कि हमारे को सीख कबाब बनाना है, but I mean, आपका कौन सा spot है in this sensory map that you would like your product to occupy, right? Because I can have a Sikh kebab, which is almost like a galati, and I can have, which is called a kakuri kebab, and I can have a Sikh kebab, which is at the other extreme, right? Which is harder than a sausage or a cutlet, right, upon cooking. So where do we want to exist, right? And do you want any unique characteristics of it, key in terms of chewiness, cohesiveness? Do you want to be, because there are points at the same hardness level, I have a product here and I have a product here, right? So that varies on that chewiness quite significantly, and so on and so forth with it. So it becomes important to understand what target, right? Unless we have a target, I mean, I keep saying to my students that you can play, when if you touch a football, it'll move, right? But that does not make a game. For a game, you require to put a goal post because every touch needs to move it to the opposition's, towards the opposition's goal, right? That's the ultimate aim. So unless you have a goal post in mind, you have a target space in mind, we will enjoy our journey of touching the ball and it moves. That gives a certain sense of excitement. But after a year or so, we are not sure where we have ended up, except that we've had fun with the ball for about a year or so, right? So defining a goal becomes a critical task, and then being able to measure our progress towards a goal. How do we measure? What do we put as a metrics becomes important there, right? In this space, once we have figured out, okay, we have some metrics to go, we have charted our existing products, and now our goal is let's look at a new material, not a animal-based material, but a plant-based material, and see if we can fall along this line somewhere, right? That's our goal. So therefore, it is good to start looking at how will I do this whole process, right? If I just take a protein powder and I add water to it, I get something like a paste, right? Or a dough, right? It is not fibrous. It doesn't mimic meat by any standard, right? So we have to figure out a way that how can we introduce a texture, a fibrous texture to it, right? And if we go and read up about plant proteins, we understand that, hey, plant proteins are actually globular by nature, and animal proteins are largely fibrous in nature. So our first thinking is, can I go from globular to fibrous, right? Which means maybe I can open up the structure, unfold it, stretch it out, and then keep it stretched out, layer all the stretched pieces together on top of each other, align them, and then stitch them together so that they start appearing, or at least give a sensation of fibrousness in my mouth, right? And maybe I can introduce juiciness in this, I can introduce succulence in this, and various other things, right? So we put the whole process in place, and we say, hey, there needs to be one step of taking a plant protein, and if I just do with a plant protein, I mean, just do a plant grain which is rich in protein, such as a dal, and grind it down and try stuff, I realize that I can't do much with it no matter what I try. And therefore, the thought that, okay, I will need to get rid of a lot of other things so that I can align what I want to. Otherwise, there's too much of interfering material in terms of starches, in terms of fats, etc. So I will need to isolate my protein. I will then need to, and usually isolation will happen in some kind of an aqueous medium. So then I need to filter out to remove the water. Then I need to granulate it to get a dry powder. And a dry powder alone doesn't seem to do the job. So I probably need to blend 2 or 3 different protein source powders together. So I create a dry blend, which can I then probably can expose to our fundamental forces of heat, of and of shear and pressure, and hope some transformation happens, which gives me a what I call as a designer protein, right? That's the thinking that a food physicist, a chemical engineer would come up with. And over 40, 50 years of trials, people have figured out. I mean, the earliest attempts, Henry Ford, they say, made a car with proteins, right? Using the spinning technology. But today, we have the twin screw extruder as the leading technology for this, because it has a certain number of advantages. I'm not going into the advantages of a twin screw extruder versus other technologies and why, but that's for another day. But twin screw extruder, along with a cooling die, which is almost of a similar dimension and length to the extruder itself. The extruder itself needs to be having a very long L by D, a high L by D, typically of the order of 20 to 40 to do the job that we want it to do, and followed by a cooling die, which is also of a very similar length, at least half the length of the extruder, to be able to get a consistent product, something which is giving us a very fibrous texture, and which can create the kind of succulent products that we want to. So that's the first part, is therefore the granulation of the protein itself in its pure form, then creating the blends of the proteins from different sources, then compounding it and transforming this solid powder into a melt and extruding into a structured designer protein, and taking that designer protein and converting into a finished edible product, which is the culinary process. So there are 3 plays. There is the play with the proteins, there is a play with the operating parameters for the extruder, and there is a play with the binder systems that you have in the culinary process. And the whole art is, and the sciences and the tech is around these 3 plays, right? Act 1, Act 2, Act 3. In another way of looking at it is this chart, which I like. Being a process scientist, I've put processes in the center. At the right side, cohesiveness, springiness, resilience, chewiness, cutting strength, hardness, those are consumer lingo, right? So we want to deliver a certain profile of this for a target gold standard product that we've understood very well. And it'll take 2-3 months to understand a product if you really want to go into it, right? And from there, we say, I want to now select the right raw material for it. I need to select my right equipment configuration. I want to set the right process parameters. I also want to put in the right culinary part in there. So this becomes our the left side and the right side. And if I'm just focusing on creation of the designer ingredient rather than the culinary part, then our focus in between is, how do I go from this RM, equipment configuration and processing parameter, to getting the texture for the designer protein, right? And once I have the texture of the designer protein, I then from there need to go to my mincing cycle to get to the culinary product. And in between, when I change parameters here, I'm actually changing a first generation, like I'm changing the torque, I'm changing the pressure profile, the resonance time, the distributive mixing, the dispersive mixing, the thermal exposure, and trying to change those to impact the physicochemical properties of expansion, of air entrapment, of viscoelasticity, of gelation, of emulsification, of fibration, right? And hoping that the right physicochemical understanding and the right property mix will then result in the consumer relevant properties of hardness and cohesiveness and chewiness and resilience and springiness and so on, right? So that's what we are trying to attempt, firstly with the designer protein, which is what this slide focuses on, and then similar thing for the culinary process that we want. So to be able to do this, of course, is no mean task, right? You require a lot of capabilities together to be able to do this. So we set up working on this and conceptualizing that we wanted to work on this area about 5 years ago, right, in our lab, because we had to conceptualize what we wanted to do. We had to then raise funding for this, write proposals, and set up facilities. So what is all that we require, right? We require milling and sieving operations, extraction. We want concentration, so white film evaporators for concentrating, spray drying for drying to get to protein powders. You then need, once you have protein powders, you require a twin screw extruder with multiple dies, multiple screw arrangements to be able to do the dry TVP process, to be able to do the high moisture process. So we set about looking at a twin screw extruder with a cooling die that we needed to buy, right? And then the whole structuring laboratory, right? What comes out is a designer protein. I need to convert it into a product. How do I do that? So we said, okay, we require different kinds of blenders, planetary blenders, single and double ribbon blenders, paddle blenders, mixed blenders, vacuum blenders, etc. We require different kinds of mixers, coating pans. We said also plant milks should be a possibility. So we said, okay, high shear homogenizers, the double stage, the GEA1, the Silverson, which is a batch kind of a homogenizer. So let's put those also so that we can create plant milks, we can create the egg kind of consistency, etc. So we said those as well in the structuring lab. So that's our structuring lab. And then we have the kitchen, which because finally when this comes off, after you've minced the product and blended it in the various blenders and homogenizers, etc., then you come to the kitchen because you need to cook it. So you require maybe a combi oven, you require a Mary Chef kind of flexible oven, you require deep fryers, you require sous vide kind of cooking, you may require a Vitamix or a Omega mincer or a rotary evaporator, you require maybe liquid nitrogen, centrifuges, so all those things. So we said, let's put up this kitchen together as a facility to create prototypes, right, which are for consumption, with the consumer facing prototypes. And then to be able to evaluate everything, whether it's the consumer facing prototypes or the designer intermediate ingredients that the consumers don't see, you require things like the texture analyzer, you require the Minolta chromometers, you may require the DSCs and the viscometers, etc. And then you require, if you're looking at aroma profile, I mean, taste may, flavor may, you have the tongue and you have the nose. So you require GCMS to be able to understand the aroma profiles. You require HPLC, FTIR, you require your wet chemistry for phytochemical analysis, proximate analysis, solubility of the proteins. You require electrophoresis to look at the sizes of the protein. So it's a vast set of laboratories, instruments, expertises that you require. So we said, let's just go about setting this in place. So today we are nearly there and we have most everything in place here, right? In our, as a 1 point place to do an end-to-end product development. And next few slides on just one aspect of it, right? Which is, say, for example, if we have a certain protein to evaluate, yeah, you bring a protein from some source and say, hey, let's just try and make a textured designer protein with it. We run a series of runs with it, right? This is just a 32 run sample that we have, that we run for any single protein or a combination of proteins, right? And there are a few parameters to look at. We have different protein levels, we have different moisture levels, we have different feed rates that we feed it, we'll have different screw rates, and we have different temperatures, right? So here, for example, two temperatures, 110 and 150 degrees centigrade, that's the extreme right? Then screw speeds, we have used a 300 RPM and a 900 RPM. Two different feed rates, 5 kg per hour and 10 kg per hour. Moisture content 60% and 70%. And protein levels of 60% and 70%. So it's a 2 by 2 by 2 by 2 by 2, right? 32-point experiment that we have created, right? You could go for more points as well. We have a deeper dive which runs into about 200 plus samples as well. But this is the shorter minimal that we require to understand the space, right? And once we run this experimental set with these defined sets of conditions, it gives us a very good idea about the kind of textures that we can get for a high moisture product. And similarly, we would run this for a dry TVP process as well. And then create maps. Just giving one map, for example, this is the hardness, this is the runs, the runs 1 to 32 are there. And for each, the hardness is given. And then how hardness changes with respect to temperature. I said two temperatures, 110, 150, how it changes with respect to RPM, how it changes versus feed rate, how it changes versus moisture, and so on, that we can start plotting and understand how that particular protein behaves and what will be the textural property coming out. So it's quite an intensive task. But as I said, once you have a design set and you're following what I started off with Galileo's statement, there is a method to it. There's a method to the madness, as I said, and you come to products, consistent products coming out, of your extruder, and you can vary the fibration length, the textural qualities, the tonalities of the whole material. So play with the texture, play with the color, right? Play with the vibration, etc., and create a variety of samples to choose from. You also could do a lot of protein level evaluation using the physicochemical even before we get to that, by looking at each of these things plays a role, right? Particle size distribution, protein content, the amino acid profile, the racemization, the solubility of the proteins, even going further into 7S and 11S, the cross-linking, the gelation quality, the emulsification, the viscoelasticity. So a lot of physicochemical analysis, even at the protein end, even before you get to the extrusion, has that understanding itself makes a big difference. So for most of the serious collaborators with us, we begin right here with the physicochemical understanding of the proteins first. Lab, even before we advise them to get into, I know everybody's in a hurry to let's use the extruder and show us what comes out. And we do that when people want it to, but we find that doing the second part, understanding the protein first, is extremely important before we actually get to this part, right, and do those experiments. Anyways, after these, through the various runs that we have, we can create proteins with various textures, right? We say that this is almost a 16x hardness. You can have the designer proteins with hardness levels coming from about 1,000 to about 16,000, right? If you put a weight of 1 kg versus a weight of 16 kgs, to compress it by about half, right? Similarly, chewiness, about an 8x variation, resilience about 2.5x variation. So for each of these, these are real points for different products that we have, right, spanning across. And the lines that are connecting is for one material that I have at the lowest hardness, lowest chewiness, somewhere top quartile, bottom quartile, ke top pe resilience, bottom in cohesiveness, then springiness up there. So you can create the face of your designer protein that you have. And then this was just one protein, but another important aspect is to understand how the fibration is created from a fundamental perspective. And usually fibration, plant proteins, is not just about opening of proteins and then gluing them together into layers, but it is also a multiphasic system, which is two proteins or two biopolymers. It could also be starches and pectins, not just proteins, which are immiscible in each other. And you are basically stretching the two, one more than the other, and creating that fibration, right? That's the other theory, which other model of plant proteins, right? That people talk about, and probably the more popular one amongst food physicists. And therefore, playing around with your protein isolate, the primary isolate, which the lowest cost is soy, but the other ones which are available, say yellow pea and chickpea, are quite popular as well. Are the secondary biopolymers of wheat gluten, the concentrates, of various things like the soy concentrate milega, which are not fully purified proteins, and therefore have a lot of other stuff for the defatted flours, or the starches and the fibers and the pectins that you can get. So playing around with those ingredients creates a whole variety. And this is, for example, one map that we have one protein and we can process it. Any one color shows the variation we can create by just processing it differently. But then we have blend B, blend C, blend D, blend E, that we can actually create no differences between, say, this protein and this protein. There is a difference created. Both of them have the same hardness level of about 9,000, but one has the chewiness about 400, the other about 800. So I can change the hardness to chewiness, right, by adding a second ingredient in there and play around. So that gives us a textural control, right? That's what this try to points out. And now coming on to the productization, this was about the first part, which is the designer protein part. And now we have the designer protein with us of the desired textures. And then we have to convert it into a product. So you pick up any product from the market and you look at a list of ingredients, and there are a whole lot of ingredients in there, right? Of course, texturization ke liye to 2-3 ingredient hi chahiye. You don't require much. You just you give me an isolate, and I will add water to it and give you a textured material. So we can do with just 2 ingredients, water and isolate is sufficient to create but to then go from there to creating a product, we add a lot of stuff. No, घर पे भी हम 50 चीजें डालते हैं बीच में. You will have haldi, you will have namak, you will have so many other things. हरी मिर्ची डालोगे, लाल मिर्च डालोगे, जीरा डालोगे and stuff. And similarly in industrial process, you add a lot of things, right? At home, I put breadcrumbs in there, I put anda in there, etc. I make plant protein products at home almost on a daily basis, right? My refrigerator is always there's some plant protein available because I have a pilot plant to make things, and I bring some part of whatever I make every day home and cook with it. But this is how an industrial process will look like. And especially if you are then going for a vegetarian claim, then of course you don't want the egg and other stuff that I could do at home. And so you are looking for industrial recipes. And so you start looking at various binder systems. You also want to add fortified with your vitamins, etc. You want antioxidants in there to have shelf life, right? And so the list of ingredients grows, right? And so this is one from which companies? This is Impossible Foods ka, right? Is the plant list. And so each of this will have an impact, right? And along with the ingredients that you're adding, especially the binder systems, such as the methyl cellulose, which is listed here, you also have stuff to play around with. How do I mince my designer protein, right? 3 mm, 5 mm, 7 mm. This is just the die ka mince ka diameter, right? Of the holes in this die plate. The mince cycle, should I mince it only once, or should I take this mince and put it back up there and do a 6 cycle or a 12 cycle? Especially if you're doing galauti, you want to mince it again and again and pulverize it almost to a paste because you want a melt in mouth consistency, right? Galauti was created, actually all mince products were created, if you imagine, 100 years ago. Pretty much at 40, nobody had good teeth left, right? So your meat was a very young person food. And at 30, 35, you could not eat meat beyond that, right? And so people who wanted then figured out a way that you can go to mince products. And amongst the mince products also, the galautis were the ultimate. The galautis and the kakuri kebabs are the ultimate melt in mouth. कि जिनमें दांत ही नहीं है बिल्कुल तब भी खा सको, right? And so that's so therefore mince cycles play a big role. The binder systems are the molecular gastronomy end of the methyl celluloses, the carrageenan world, and how much to add, which ones to add. And then of course the blender types. I mentioned the ribbon blender, right, which is shown, or the plate blender, the mix blenders, the planetary mixers, the vacuum. Which one do you want to go to for what product, right? And so there's so much available that you can spend a lifetime exploring each one of them scientifically if you wanted to. But of course, from an innovation perspective, you want to decomplicate things. And that's what we try to do in our lab, that it's a complex world of plant proteins. And how do we uncomplicate it for the innovators and make it simple for them to move from an idea to market as soon as possible, but yet with all the metrics, and so that they get a good understanding of their product as they scale, right? And these are just showing you some thoughts around that. Depending on how much of methyl cellulose that we've added, my hardness can change quite a bit. So it's not only that I'm controlling, I spoke about hardness levels almost going 16x, right? Based on my processing, that I could have a hardness of 1000 and have a hardness of 16,000 G at the processing end. And similarly here, this is for a mince product. I have my hardness of 200 and a hardness of 2000 by adding a binder to it. Right? So that's another flexibility that I have. This is just looking at the cooking time itself, right? कि ये binder system जो भी use किया था किसी ने, we took someone's binding system, and you can see that this is the uncooked product, and the cooking ke saath, depending on how much you cook, right, the hardness level is changing quite a bit. This is probably the desirable level of hardness, around 1000 for this product. But we said, what if I'm making this at home and ghanti baj jata hai, put it on the gas, and I can't take it off in 4 minutes because somebody's come to the door. By the time I come back, it's become 8 minutes or 10 minutes. My hardness is doubled, right? So this is a binding system which is very thermally sensitive, right? And so maybe if I'm preparing a product for home cooking where things could go off by a lot of margin, versus a industrial recipe where the cooking happens either in a restaurant kitchen, which is way more controlled, or at the end of in a factory where things are more controlled. For home use, I have to be mindful that there's a huge variation in cooking time, and my product can be stone and my product can be very nice and juicy, right? So having to make sure that my binder system gives a very consistent product, no matter whether I hold for 4 minutes or 10 minutes, becomes a key there, right? And so those are some thoughts that I thought I'll just share with you and open it for questions and discussion. But just a few, just the last slide here saying that, hey, if you want to design products, then understanding the target is number one. Don't ignore that. Spend a lot of time understanding your target. Just saying, मुझे सीख कबाब बनाना है, मुझे मोमो बनाना है, मुझे ये बनाना is not sufficient, right? Then play with your protein blends, play with your extruder, play with productization. Largely, I suggest the last two, extruder and productization variables, more than play with proteins, because proteins go with your cost, will depend on which protein you select. And make sure you are selecting a protein where the supplier is kind of guaranteeing you कि मेरा profile यही रहेगा proteins का, right? So ask a few more questions about not just कि soy protein है या नहीं, but look at their size profile, look at soy protein में at least do the basics about its emulsification, its aeration, its gelation, its protein solubility. So quantify that so that you can next time go to the supplier and say, hey यार ये बदल गया आपका, right? But the other two are things to play around with, extruder and productization. And if you're already buying a designer protein, because many of you must be buying designer proteins from some company, they have a dry TVP or a HMMA product available. Largely in India, it'll be dry TVP, which will be available. Then you have the first two are out of your hands. You just want to make sure it's consistent, and then get into the last play, right? And focus all your energies there. So with that, I'll end my slide deck. This is my email address if anybody wants to reach out. Also giving you Abdul Mateen, who works with me in the lab and handles the extruder and is an expert as well, right? Our internal expert on the plant proteins area. And you can reach out to him. Many times it's easier to reach to him than to me. And our university, as I said, is a little beyond Yelahanka in a very nice scenic setting. If anybody wants to just drop in to see what our facilities look like, you're most welcome to drop in if you're in Bangalore, right? Cool. I'll stop here and open up for discussion.
Fantastic. Thank you so much, Dr. Gurmeet, for that session. I think a lot of aspects that you covered were so simple to understand. And we've been getting comments in the chat and DMs that everybody had a really good time just listening to you. Having said that, I think Devika can cover the next set of questions that have come in. Devika, do you want to jump on board?
Yeah. Dr. Gurmeet, if you want to just press the Q&A tab, you can see a bunch of questions that come in, and I can also read them out for you for your convenience, but if you want to see them as well.
Okay.
So while you're taking a look at it, Dr. Gurmeet, I think one area which we can touch a little bit upon is there are some entrepreneurs with us in the challenge as well, and people who want to set up a manufacturing facility, or at least want to understand what is that essential set of key equipments and infrastructure from all the different, across the food science, um, sensory, manufacturing, processing domains, all the different equipments that are needed, and also get an understanding of for those essential kind of set of equipments, what kind of costs can somebody go on about expecting, whether it's lab scale, pilot scale, whatever numbers, even if they're tentative or in the range that you can share, perhaps to build this context out, would perhaps be helpful for people who have joined with us today and also at large for the community when they see this recording.
Yeah. I mean, yeah, in terms of equipment, I mean, I will, so depends on what you want to do, whether you want to make the designer protein. I mean, there are three parts, as I said. One is making the protein powders, right? The isolates. The second is you take the isolate and convert it into a designer protein, an extruded texturized protein, either a high moisture or a dry, yeah, TVP. And then the third is that you are taking a texturized protein and converting it into a product such as a seekh kebab, a sausage, a cutlet, a nugget, etc. And you could play either in all three or any two, right? Or in any one, right? The lowest cost, of course, is to get to, if you are at the consumer end of it, is to buy a TVP, a texturized protein, and focus your energies on converting it into a product, right? There are third parties available who will do this job for you, but then you don't differentiate versus anybody else. So if you set up your own lab and create your own, select your own binder systems, create your own spices, your own flavors, etc., before you hand it over to a third party for manufacturing, it starts giving you a differentiation, right, in the market space that you can then build on and backward integrate into wherever you want to. So third party manufacturing, which means you have zero capex now, right, and your capex is all invested in the supply chain part of it, right, which is where if you're at the consumer end of it, if you are looking at creating the designer proteins, then a extruder, I mean, then you have to take a call. Is it dry TVP or it's a high moisture, right, that you want? If it's a high moisture twin screw extrusion, for both, I would suggest that the one technology which will survive is a twin screw extruder, right? I mean, there's a lot of people who come to me and say, we don't know enough about, there is not enough knowledge in India about this or that, or right, I would say, and so they're worried about कि technology outdate हो जाएगा, कुछ नया हो जाएगा. No, those are thoughts coming from when you don't understand technology, right? When you understand technology, you realize that it takes 30, 40 years for a equipment, research on an equipment, for it to start becoming popular. And twin screw extruder, there are about 10,000 sold by just one company, right? Out of which the applications for food, I think about 3, 4, 500 out of those 10,000 have been for food applications. So it's a very well tested system for decades, right? And so you can't go wrong with it. It's also a system of the future. So for the next, if you buy one for the next 50 years, ऐसा नहीं है कि कोई नया technology आ जाएगा suddenly and which will beat you to it. This is a technology which is there to stay, and it's a very flexible technology. You can create multiple products with it. So it is a good investment, but it's a heavy investment as of today. 500 kg per hour extruder, just the extruder itself would cost you like 6, 7, 8 crore rupees, right? 500 kg of 70% moisture HMMA product, right, coming out would cost you 7, 8, and then you require other paraphernalia. I don't know what. It all depends on a brown field or a green field setup that you have, but typically just putting in all the other things because you require storage facility, etc., cold storage if you're making a HMMA, so it would come to some 20-30 crores ka to ek operation ho hi jayega, which from a food perspective is, I mean, we may think it's high, but I think anything around 100 crores is not a massive funding for a good food factory. So it's not that expensive. In fact, in terms of simplicity, this is one of the simplest because it's a small footprint, single machine which does 10 unit operations, right? Versus most of the other such operations may require 10 different unit operations, and then you're looking at moving from one operation to the other. Material kaise leke ja rahe hain? Most of them are batch operations. So in terms of ease of operation, eventually, if you understand the technology, yes, you require greater expertise to run this, but there are advantages to this, right? I certainly see extrusion as a very exciting area, but then I'm an academic. I'm not putting my money in there, right? So I'll qualify with that.
Thank you,
Hopefully that
Dr.
answers
Gurmeet.
your
Yeah, no,
question.
absolutely. I mean, to an extent, for sure. I think can you also share your thoughts about extrusion as an area of innovation versus other upcoming areas of texturization, shear cell, electrospinning, jet spinning? I know a few teams focused on these areas of texturization last year as well, to further make it future proof in terms of thinking about what could be possible, where costs could be cut down. Could you also speak to that with a comparison to high moisture extrusion, and where do you see in the next, say, 5 years, 10 years, given the fact that the sector is altogether quite novel, and even for established technologies like extrusion, significant modifications or improvements will need to be made across the process, and what would those opportunities might look like?
Yeah.
It's a broad kind of question, combining 2-3 questions that I've seen in the chat. Yeah.
So, I mean, so I'll answer from my perspective, right? And I have only so much of experience, right? I have a lot of experience with extruders. I do not have with the spinning technologies, but of course, spinning technologies are older than the extruders, right? My dad was a spinning person, textile engineer. So fiber spinning, and that's where protein fibers also started there, right? 100 years ago. So spinning as a technology is quite old. But my sense is that when it comes to creating textured foods, there is hardly anything that can beat a extruder. And if you're looking at a high moisture, actually for any protein product, high or dry TVP, I would suggest a twin screw extruder. Of course, high moisture one will require the cooling die, so you also require the die technology, whereas the dry TVPs are the first generation where you had the extruder and then the small heating die, right? And so that's the big difference between the two. And when you buy an equipment, certainly, so the other technologies, the shear cell, etc., are smaller technologies. If I look at a time scale, then I mean, the twin screw extruder is like a 50-year-old technology, very well understood, rheology, etc., right? Forces, materials of construction. If you go to an established player, they know the ins and outs of it, right? Through a lot of experience. A lot of that experience has actually come from the polymer industry, the pigment industry, but the applications are growing today. Food is one, but pharma is taking off, right, with it. If you are looking at flavor encapsulates, looking at pet foods, looking at chewing gums, I mean, so many products coming out of extruders. So it's a very versatile technology. And if I had to put my money, I would put onto a twin screw extruder. I would not look at other technologies. And I would go with that. It gives a lot of flexibility. And if you are putting up a extrusion plant, you want to be able to up mujhe protein do, and I want to be able to create 10 different textures for 10 different products. I can do that with one unit operation, right? Very easily. Those rules are well understood for twin screw extruders. They have to be generated for others. The scalability is also very early on in for shear cell, for example. It's one company who does that, right? I would never buy a equipment with only one. If I'm putting my money in there, right, I want to make sure that there are multiple suppliers of this machine, which gives me confidence that this technology has gone beyond one person. And so those are some rules that I use in my mind, but you have to develop your own rules there. As I said, I am an innovator as well. I have a little company, so those are the rules I follow when I look at what technology to go towards, right? Yeah.
Thank you so much. No, excellent practical and kind of insights for entrepreneurs, or at least budding entrepreneurs, in our cohort of ISPIC 2021. Also, perhaps you could highlight a little bit more about the existing practical challenges or the research areas, the white space opportunity areas on improving this whole process of HME and extrusion in general to get high quality plant-based meats. That's a bigger problem that we are facing in the industry, right? Mimics which are inferior quality of meats are perhaps being launched in the market, which ultimately affects how the sector really is perceived. And most people, for example, they would try these products and they'd be like, they are not like meat. So what would it take, and what kind of skill set and talent pool we need to build so that perhaps the researchers, the students in our cohort who after this challenge would want to make their careers in the sector can think about as areas of opportunities?
Yeah. So I think, there are multiple areas to focus on, right? Most of the products that you see in the market today are from materials which are already available, right? And based on, and much of that also comes from, because the early phase people are looking at, I don't have so much of money. I want to reach this price point. So there's also this certain sense ki since it's a new area, kuch bhi chalega, right? And so you get a variety of products which are made from materials which are, say, soy nuggets, for example, right? Ki main soy nugget leke hi kuch bana दूं और बोलूं plant meat hai. So half the products in the market are that kind of products, right? That you see. Some people get into dry TVPs, right? Or a mix of dry TVPs. I won't say everybody is into the soy chop kind of a product, but they many are mixing the dry TVPs with the nuggets kind of. Yeah, when you taste them, you can get a sense ki kya kar rahe hain, right? When you bite into them, you know kya ho raha hai. When you allow the product to cool and look at, is it mushy or is it holding its texture? You can see that ठीक है, cooking stage में तो शायद हो गया, पर थोड़ा छोड़ा तो कैसा है, raw में कैसा है. When you are creating a product, you have to look at the whole end-to-end journey. I spent 20 years in tea, as I said, and we would look at कि चाय का पैकेट खोला तो क्या एक्सपीरियंस आया, उसका छन छन कैसा है, right? And then when water hits the tea, how it's so for the person who's cooking in the kitchen कैसा impact आएगा, for the person who's drinking the tea कैसा impact आएगा, छन्नी में जो बचा वो कैसा है, how fast is the color infuse, when point is the aroma, the maximum release happening. So it's otherwise chai is chai, but why is it that one brand is selling 100,000 tons and the others are like so small? Is because of all these. Food is a game of inches, I call, right? If the field is 100-meter field, who wins at every centimeter, right, is the one who takes. So while each of these things लगता है यार ये तो फर्क नहीं पड़ता, but the people who are there for the longer term are people who play every centimeter of the game, and not just कि मैं आज वो field को पूरा 100 meters एक ही shot में खत्म कर दिया. So there are so many things, therefore, at every stage that you have to focus on. And if you focus on these things, the ingredients that you're using, right, to begin with, are you there as a transactor? Do you want to very quickly, what game are you trying to play, right? You can certainly make a product and put it on the shelf today, right? But if it's a frozen product, do you understand the frozen supply chain? आपने तो frozen दे दिया shop को, but वो shop वाले ने switch off कर दिया, on कर दिया. A lot of the products are mishandled during, right, the freeze. So how do you handle all those things, right from the proteins to converting into products? How much of salt are you adding to hide the taste, right? If you're buying an inferior quality protein, you have to add a lot more salt to it, right? You have to add a lot more flavorings to it. What kind of binder systems are you adding? How much are you adding? So there's a lot of it that you have to look at. Every step, as I said, every centimeter is important, and you have to pick your battles to fight. What are the more important centimeters for you as a startup? You don't have too much of resources, so you have to pick your centimeters that you want to play in, and that's what will differentiate you, right? Everyone is deciding, यार मुझे यहाँ पे I want to differentiate on this centimeter of my 100-meter field, right? At this stage, I can't win on 100-meter every centimeter, so I have to decide where I am passing. And where is it that I am standing out? Yeah.
Absolutely. No, thank you, Dr. Gurmeet. I think in general, the insights you share answer the question, not very specifically, but it gives the candidates a way of thinking around how to solve for those kind of questions that might be coming to them. Now, in light of the same, I have a couple of questions on deciding what ingredients to go for, right? Especially in protein sources from plants, soy, wheat, and pea protein, for example, are the recent ones which have been used globally and are getting quite the interest from corporates and perhaps researchers alike. Would you also comment on what kind of, say, proteins or plant protein sources or the alternative protein sources you think would be perhaps the next hero categories or next sort of big ones in the plant-based meat game?
You mean as the plant sources for it, whether it's soy or pea or etc., right?
Correct. So in terms of protein functionality or other characteristics, or perhaps balancing for the supply available or
Yeah.
opportunity to decrease cost, etc., etc. Yeah.
Yeah. I mean, my guiding principles, I mean, you have to look at what you have to do to arrive at this is put down yours, your criteria for selection, right? Cost is one, for example, right? And I think GFI has a very good chart on it, right? Where they have some 10, 15 criteria for different proteins and a green to red rating for each one of them, and assessment of, that's a good chart to start off with. And then decide what do you want, right? Uh, do you want to be the lowest cost player? If you want to be the lowest cost, you need a very good reason to move out of soy. Uh, why would anything become cheaper than soy? I don't know. I've not seen anything in literature or in supply chains to point to a fact that any protein will become cheaper than soy. Any other plant protein will become cheaper than soy. And then you have to focus on soy. Which soy supplier do I go to? Rather than, no, let me get lost. Do I want soy? Do I want pea? Do I want chickpea? Do I want fava bean? Do I want amaranth? Right? But if you want to claim that my protein, my doesn't have soy, right? Because, hey, in some consumers' mind, maybe soy is taboo or wheat gluten is taboo, right? Or wheat gluten for reasons not just because लोगों के दिमाग में है, but also because there are some issues, right? Digestibility issues with gluten, allergies, etc. as well. Soy isolate ke sath, I think the allergy issues are lesser. This is not soybean. Soy isolate has removed everything else from it. So it's not as, most dals we are not able to digest because of the non-protein part, the indigestible carbohydrates which come along with the legumes. That is why people can't digest chana or chole, etc., or some most dals, except for mung dal. So, but when you go to soy isolate, you've removed most of that stuff, right? So, a lot of the other stuff is misconception which is there, right? But you have to have solid reasons for moving out. Soy also wins on account of its completeness in terms of its amino acid profile. With the other proteins, you have to add something to it. So you have to look at cost, then you have to look at how clean. If you're looking at supplier, then you're looking at how clean is my product coming, right? The off taste, there are suppliers which will have off taste and there are suppliers which will have very clean products. So if you can identify a supplier which has a cleaner raw material, then it's an easier recipe for you later on, but he's going to charge for that. That supplier will charge for that cleanliness. So it's at every stage, you need to have your decision criteria very clearly stated, right? It is cost. Do I have 2, 3 suppliers, or only I'm putting my whole business commitment for one supplier, right? That's a risk. Where do you want, how do you want to de-risk your business? And then, of course, does it have a complete nutritional profile? Does it have a neutral taste? If you are making a chicken kind of thing, then you want to make sure that it is not just clean in taste, but the color is also very light and Maillard reactions haven't happened, right? So all those, you have to put all those things down on a spreadsheet and start making your decisions as to what is my decision. So, long ago, 20 years ago, by chance, I had 2 cars at that stage. One was a Santro. Big fan of Shah Rukh Khan. So Shah Rukh Khan came up with that red Santro. So I took the red Santro, and I had a Maruti Wagon-R, right? Both I bought because both of them have a little taller design. And so being a Sardarji with a turban, getting in and out of the car is very easy without bumping my head if I have the taller cars, right? And people would ask me कि कौन सी गाड़ी अच्छी है, हमें गाड़ी खरीदनी है, कौन सी लूं, वैगन आर लूं या ये लूं, राइट? कौन सी ज्यादा अच्छी गाड़ी है? That's a very open-ended question. If there was such a thing that only this is good, then everybody would have figured out and only one would sell, the other would have zero sales, right? Everything is good, but you have to be very specific. What is your need? What is it you're looking for? One car will have something better than the other, but the reason everybody survives is because everybody has decided which centimeter I'm going to excel in, right? And if that centimeter is what you relate with, then that's your buy, right? So here also you have to pick कि क्या protein का which part of the protein, what is it that you are going to be claiming, what is it that you want to do, what is your price structure, what's your business model that decides. It's impossible to give you one answer कि नहीं भैया यही protein खरीदो, right? That would wipe
Exactly. Very, very correct advice. Actually, I would like to extrapolate this to your overall proposal creations as well for all the candidates, not just about, proposals or focus areas on extrusion or plant-based meat, but in general, how your proposals would be differentiated, your ideas would be differentiated is, again, based on the evaluation criteria for the 5-page proposals and all the different aspects that you are planning to present, and want to build further down into a 15 and 25-page proposal in phase 3 if you get selected. How clearly are you presenting your unique value proposition? How clearly have you thought through how perhaps the different parts of the supply chain or value chain are fitting into each other? Are you asking the critical questions which would help you challenge or understand the limitations of your approach? And perhaps do you have a plan of action to basically address that? I mean, in any way, that's what a researcher would go and do about any project that they might be kind of proposing, especially in a track one kind of a context. Having said that, Dr. Gurmeet, we have 2-3 more questions. One is quite specific, but maybe you can, draw some larger insights. It's about physico-chemical properties of globular proteins and fibrous proteins. And, there is a little different shape, durability, solubility, and affect all of those properties as well. So during the conversion process and the food production or post-processing steps after that, are there any specific things to keep in mind when dealing with globular proteins, maybe through your experimentation, through your past experiences of working with different sources? You can highlight some key insights here.
Yeah, so I mean, the 3 properties which we feel are important, actually 3-4 properties. I mean, one is the water holding capacity and the oil holding capacity, right, of the protein that we are looking at, right? As high as possible is good, right? We find jitna zyada utna acha hota hai, right? The other, of course, is the emulsification, right? That in the final product, that does translate and does impact, the final product as well. And then the solubility also gives us an indication, right? When you take a protein powder, how much of it is soluble in salt? I mean, the traditional 100-year-old protein sciences, you try and dissolve it in salt, you try and dissolve it in alkali, you dissolve it in alcohol, right? And see how much of percent goes into which. That gives you a good sense of how the protein is and how it will behave during the extrusion process, right? So those are some things that we look at.
Thank you, Dr. Gurmeet. And other than that, for candidates, we have few more sessions from last year's webinar series. We had people from Shandy Global, Dr. Gaurav talking, and other couple of people, scientists on the panel talking more about these properties. We have the extrusion webinar with Wenger. There's one with TDU. So those links are already in the chat. They are on my YouTube handle as well. Make sure that you take a look at that. So one more question came in about novel products like soya chunks. Will they be more popular in the Indian market, or mimicking already popular foods like kebab would be more receptive? Just quickly adding my context. Sorry, I lost who asked this question, but for sure, right? In the context of plant-based meat, the better mimic you can create to the original product, the better. For soya chunks, it's not really a novel product now. Ruchi Soya Group, popularized it in the 90s, and before that, you might remember them being available in the market, and they have hit a specific market, right, which they set out to achieve, and that's also growing for sure. High vegetarian protein, TVP protein market will also keep growing. But in the context of meeting the meat demands and the whole theory of change that the smart protein sector has, definitely replicating and mimicking the existing products, whether it's kebabs or whether these are tandoori products or whether mince products. That's quite important, like Dr. Gurmeet covered in some of his slides. Anything to add here, Dr. Gurmeet, in terms of what you're seeing in terms of your clients or the early market test trials, etc., for these products?
No, so one general statement again about the Indian consumer, that over the last 2-3 years since I got into this area, that I've been looking at meat in general, right, is that the textural understanding of meat in India with consumers is very low, right? If you look at most of our products, I'm looking at top restaurants as well. So I visited a lot of top restaurants to eat their products. I see that they are very good with their gravies, right? With the flavoring, which is non-meat gravy जो आता है, जो मखनी आएगा या मसाला आएगा या जो भी आएगा. पर आप अगर वो हटा के उसको, so I many times I wash off all the gravy and look at the meat का क्या quality है. The meat quality is very, very substandard, to say the least, right? In many cases, many good restaurants would have very ordinary meats. Maybe they have not paid attention, or it's not cooked properly, or so. While I emphasize texture that it is good to focus on texture. If you are going for a non-meat market, or where you are not differentiated, like the soy chops which are available, right? They are non-differentiated. If you want to play that volume game, that's easier, right? But you are not going to make much margin, and it's very easy for someone to come next day and wipe you out completely, right? So you have to decide and take a call कि आप कहाँ पे या प्ले करना चाहते हैं. It's always very tempting, यार ये तो मैं कर सकता हूँ, nuggets लेके ये तो मेरा हो जाएगा तैयार, right? But the question is, you should have a roadmap ready as to how you want to move forward, right? For today, that is fine, but you should have your next step already planned, right? So.
Sure. A couple of last questions. So basically, one is about plant-based seafood and plant-based meat, and what to keep in mind in terms of process parameters, equipment, and perhaps the choice of ingredients to get the kind of different textures for both of them. And within seafood, there's just so much variety, right? Crab cake versus a fish that you're trying to replicate, perhaps. So some of those insights would be quite helpful.
Yeah. So I think, firstly, I should confess that I haven't worked too much in the space of trying to replicate seafood yet. I'm still working on the poultry and the mutton end of things, is where a lot of my expertise lies. Of course, we can make seafood products. It's not too difficult, but I've not spent too much of time trying to understand them or trying to differentiate them. So having said that, I mean, it's largely in the operating space, the parameter space that we use. The equipment are the same, and it's largely in the equipment that we do and the cuts that we do. With the we don't do the mincing kind of cuts that we do with the for our the meat products. For the fish ones, we want flakier cuts, right? So we want a flaker as opposed to a mincer. A lot of the trick happens there at that end, right, with seafood products. And then a lot of tricks also in seafood right now are in terms of shape, right, versus that. I mean, prawns, for example, people are making them in prawn shape. So it's a lot of it is going into dies, right? That each piece is going into a specific die, and you are molding it into individual units, is where a lot of the expertise lies today. Right.
Got it. So what would you say are key things to keep in mind in terms of making it more flaky or more seafood-like? What would theoretically be the parameters that one should focus on in terms of, say, the source, firstly, the protein source, selection of that, and then the processing parameters itself?
Yeah. So as I said, for me, I look at that the most important feature of proteins when I look at, I do not look at कि soy ये कर सकता है और pea protein ये कर सकता है and ये नहीं कर सकता, right? What I see is right now that most things can be done with no matter what protein source. Yeah. It's a claims story I'm playing with, right? So if you have your claims roadmap ready, see, there is no point of investing money. Maybe that's another point it's a generic point. But first think of, I always begin with, what do I want to put on the pack, right? आप नाम लिखेंगे और नीचे 2-3 लाइनें, those are your claims. What is the consumer going to see? Then I want to put my money behind what I'm going to tell the consumer on the pack or through an advertisement. Why should I invest my extra differentiation in other things which I'm not going to talk about? So have your claims roadmap ready and then step back, right? While you're doing a forward process, ki main kaun se protein se shuru karu, but also do the reverse part. What do I want to put on the back? What is going to look like, right? And then go back. In fact, we many times, I mean, every big company does it that way. They will first create a concept card, no product in mind, and get very clearly as to what is winning in the market, consumers kya denge from the concept, and then move back ki yaar iske liye mujhe kya karna chahiye, right? And so that's where you should look at as well. Proteins choices for seafood, I think, is not that critical. What you're looking for is a very clean product. So your investment has to be in looking for no taste, yeah, no color, right? Fish, agar aapko white fish chahiye, to you want the cleanest of cleanest, right? Proteins, and then processed in a manner where you are not heating them much at all. You're not going to the 120, 130 where color generation happens. You want the fibration to happen at 110 or so. So you want to go to those suppliers who can do that job, right, for you. So those are more important things, I feel. Yeah.
Makes sense. And last question, like in terms of the interactions you've been having, say with entrepreneurs or industry folks who want to commercialize this, who have probably the pulse of market, or they've started selling or doing some market research. Couple of things. How important is clean label for them? No additives, no preservatives, and how does extrusion help that? Like you answered it to some extent, but perhaps add on that little. And the second one is snack food items like crab sticks versus say chicken nuggets, in one bucket versus say whole meat cuts, right, which might be necessary for more authentic Indian dishes. How do you see that application playing, which would have the larger market? I'm assuming in the shorter term perhaps the snacking market will grow, but it will hit its perhaps peak with a lot of other competitors, and the real volume would come from the latter. But I will love your thoughts on those 2-3 questions.
Yeah. So, I mean, I'll tell you my personal thoughts in here. Now, of course, is this whole area of meat analogs, right? Whether minced or whole. Minced is the first category, which is getting tackled. And then whole is a second category. Whole may, of course, the products to tackle would be shredded pieces and curry cuts as opposed to larger pieces to begin with, right? And some people are already doing that with innovative ways, right? So that's the area to be in to begin with. I don't think we are ready for larger whole cuts yet, right? Globally as such, still trying to figure that out. But shreds certainly is a possibility. It's getting closer and closer, right? And so things like salad is not a big category in India, but salad ke liye to I think it's interesting materials are there which could be used, where you use shredded pieces of meat. Also curry cuts is probably possible. So soon maybe biryani, etc. There are already some products in that space here that you can see. So those are things. And pizza topping, for example, which are more maybe sausagey, mince, but so those are things that people will try and attempt. Momos, etc. A lot still can be done in the minced space. And as I said, India is, I mean, we all realize, and it's a point JFI also keeps making, that in India, it's not one big category like a burger, which is going to be the winner. There are micro categories, which means that there is opportunity for a lot of people right in there. So as opposed to two big players ruling the market, it will not be the case in India. There are a lot of micro players. And when we say micro, these are still opportunities of hundreds of crores. It's not like bahut chota opportunity hai, right? But a lot of opportunity in that space. But I also see an opportunity that consumers are, that I don't see most of the first generation entrepreneurs looking at, which is the vegetarian market. I mean, the non-meat, that it does not need to imitate meat or match meat, right? It's a novel way of consuming a plant protein, right? अगर दाल से बोर हो गए हैं तो next चीज क्या है, right? Is the way you have to look at it also, right? And so some innovators in those spaces could also that don't. Yes, it provides a texture which is going to be always more fibrous and therefore associated with meat for the meat eaters, but it doesn't need to be 100% there as well. If you can create interesting dimensions to it, right? Yeah. Shardul, are you there? Yeah.
Yes, sorry. I think my net just dropped. Thank you so much for adding those thoughts in, Dr. Gurmeet.
I lost your voice, Shardul.
Yeah, no, my bad. So basically, that was it from the questions end. So, like Dr. Gurmeet said, high vegetarian protein category, just rounding out the discussion, will keep growing. For the challenge, obviously, we are focusing on innovation and applications which are removing the animal products from the ecosystem. So, meat, eggs, dairy, and seafood innovation across the three technology areas. But I think all the insights Dr. Gurmeet were able to share today were quite helpful for me personally as well, to just understand a little bit more about the whole um, thought process while going on about thinking about extrusion, HMEs, manufacturing of plant-based meats. And we hope that you go through all the resources that are going to be shared with this session and also in the chat, and make sure that you catch up and share those amongst your cohort members as well. Thank you so much once again, Dr. Gurmeet, for taking the time out and joining us today. I really want to thank you on behalf of all the attendees for the challenge. And we hope that a lot of interesting proposals come our way from the texturization and extrusion bit of our problem statements. Thank you once again for joining us.
Thanks.
Bye. Take care.
Bye.